This screencast is about quantum numbers, and it's part one of a two-part video series on how to determine the quantum number for an atom. So a quantum number is the electron's address. It describes the location of the outermost electron for the atom. So just like you put down a zip code to let people know where a letter is going to when you send it in a mail, this quantum number is like that last electron zip code. It tells us where to look to find the last electron in an atom. It's a 4-digit number set, and it's unique for each element of the periodic table. The quantum number relates to the periodic table and was developed by Schrödinger. This is an example of a quantum number for hydrogen. We have 1, 0, 0, negative 1/2. So as you can see, we just list the numbers of the quantum number in order, and that tells people the location of the last electron in the atom. This is determined by a lot of mathematical probability formulas. We're not going to be talking about the math that's involved. We're going to be talking about the results of that math. So let's take a look at our first quantum number. This is referred to as the principal quantum number and is called the N number. This describes the energy level of the electron. So recall when we've drawn Bohr models, the first energy level, or ring around the nucleus, can hold 2 electrons. The second energy level can hold 8. The third energy level can hold 18. So now we're not looking at those rings that are around the nucleus that we drew when we made a Bohr model. Now we're just referring to a number to let people know which level the electron is on. These will be whole numbers from 1 through 7 on the periodic table, and they use the row number for the periodic table. Transition metals are going to have row -1, and lanthanides and actinides will use row -2. Don't worry about those 3 terms right now. I'm going to show you exactly where you need to write that on your periodic table. So here's a sample periodic table, and what I want you to do is we're going to start by moving some things around. Alright, so the first thing I want you to do, actually before we move anything, is to write numbers. Write the row numbers down beside the periodic table. So 1 through 7. These represent the energy levels. So there are 7 rows on the periodic table. You want to number 1 through 7 beside those rows. The next step you want to take is to move helium. So cross it out from the noble gases and move it over here beside hydrogen. Now, helium does not normally fit in here, but when we talk about quantum numbers and other information with electrons, helium actually fits in better over here on the periodic table. It's still a noble gas, it still has all the properties of a noble gas, but just when we're dealing with electrons, to make it a little easier, we move it over here. The next thing I want you to do is locate these elements on your periodic table. It should be LU and LR, and I want you to draw an A in the first box in row 6 and then an A down here. These are the lanthanides, the top row. Down here at the bottom of the periodic table, those are the lanthanides. And here for B, I want you to put a corresponding B down here. These are the actinides. Okay, so we're going to be jumping around a little bit, and I'll explain these letters a little bit more when we get to them. But just know when we get to this section of the periodic table, we have to drop down here, and we get to where it says B here on the periodic table, we need to drop down here. Okay, so the next thing I want you to do is right on your periodic table, the principal quantum number is the energy level or the row. So when I'm in this section of the periodic table, it's just my row number. So if I'm down here in like row number 5, my principal quantum number will be 5. Over here, I'm also just using my row number. So if I'm, here in row number 3, my principal quantum number would be a 3. This middle section of the periodic table, this is where I said the transition metals are your row number -1. So let's say I'm over here in row number 6, and I want the principal quantum number. I take my row number 6 minus 1, so my principal quantum number would be a 5. Down here in these bottom 2 rows of the periodic table, this is where I write my row -2. So if I'm down here, remember this is actually part of row 7, my principal quantum number will be 5. Take a minute to jot this diagram down in your notes. The second quantum number is called the orbital quantum number, and that's notated with a cursive lowercase l. And this describes the shape of the orbital. And there are assigned areas on the periodic table for this, and they correspond with what I had you draw from the previous slide. So if we're in these first two columns, it's the s orbital, and it's assigned a number value of 0. If we're over here in the last 6 columns of the periodic table, this is where the p orbital is, and it's assigned a value of 1. In the middle where the transition elements are, this section of the periodic table is designated with the d orbital and is given the assigned value of 2. And down here in these bottom 2 rows, this is where we find our f orbital, and it is assigned a value of 3. So if you want to, you can actually add this information onto the periodic table that you previously drew. So you want to include that this is the orbital quantum number, and it tells you the shape of the orbital where the electron will be found, and it's based on the section or the location on the periodic table. So anything again in these 2 columns is going to be given a number of 0. Anything over here in these 6 columns is given a number of 1. Anything in the middle section where the transition metals are is given a value of 2, and down here in these last 2 rows, the lanthanides and the actinides is given a value of 3. So to determine the quantum number, all you're really doing is looking at that element's location on the periodic table. What I'd like you to do is copy down these element symbols and find the first 2 quantum numbers for each of these symbols. Use the periodic table and your notes to help you. So pause the video now and copy down these symbols and determine the first 2 quantum numbers for each of these symbols. So here are the answers for your first 2 quantum numbers for the element symbols that were provided. If you have any questions about how we got these first 2 numbers, please make sure to jot your questions down in your notes and to ask Mrs. Benke when you are in class. We will continue finding the remaining 2 quantum numbers in a future screencast.